A polynomial is an expression that can have constants, variables, and exponents, but no division by a variable. A variable exponents can only be 1, 0, 1, 2, 3, etc. It can have an infinite number of terms. An example can be 5x to the second power minus 3x plus 5x to the third power minus 3. These are no examples like 3x negative 2 or 2 divided x plus 2. Those are not examples of a polynomial. How to find zeros in a polynomial? First, we have the polynomial. We see this number and this number, so we find the factors of this 45 and 2. What are the factors of 45? They are, let's use the calculator. Okay, I'm using it. Okay. So 45 divided 2, it's not 1. It's 1, because 1, yes. 45 divided 3, 15, so 3. 45 divided 4, no. 45 divided 5, yes. So 5, 9, 15, and 45. So 1 times 45, 45. 3 times 15, 45, 5 times 9, 45. Okay, then this one. It's 1 and 2. Now, we do this. So the actions are 1, 3, 5, 9, 15, 45, all positive and negative. And then 1/2, 1/3, 1. Nope, sorry. It's 1/2, 3 twos, 5 twos, 9 twos, 15 twos, and 45 twos. Okay, these are the zeros. Now we have to find the actual. So we plug it in this. So it's 2x to the 4 plus 9x to the 3 minus 8, 7x to the 2 minus 49x plus 45. Then we enter it, then we go to second graph. We plug in these numbers. So 1, enter. We have 1. So we already know what the actual zeros are, but we can do it with synthetic division too. Let's prove it. So we know that 1/2 can be a 0, so we do this. I'm going to do example. So I have this, time you drop 2, this times this equals 1, this added equals 10, this times this equals 5, you rest it and it's 82 negative, then that times this equals 41, you add it, negative 90, and then, ooh, it's a 0 because you add it, it's a 0. So you get a 0 here, it's true. And as you can see, I tried everyone, it equals 0, 0, and 0. So we had the answers correct. An example of a polynomial in a word problem is a box with no top is to be made from an 8-inch by 6-inch piece of metal by cutting identical squares from each corner and turning up the sides. The volume of the box is modeled by the polynomial 2x4 plus 9x3 minus 8 87x2 minus 49x plus 45. Factor the polynomial. The multiplicity of zeros. A zero has a multiplicity, which refers to the number of times that its associated factor appears in the polynomial. For instance, the quadratic x plus 3 and x minus 2 has a zero x3, but it's negative 3, this is 0, and plus x2. These are the zeros, and they are just 1 and 1. Each occurring just 1. The 11th polynomial is x plus 3 to the 4 and x minus 2 to the 7 has the same zeros as the quadratic, but in this case x, the 0 is a 93 and 4, so it has a multiplicity of 4 because the factor x3 occurs 4 times. The factor is raised to the 4th power, and the x2 solution has a multiplicity of 7 because the factor x2 occurs 7 times. So this depends on the multiplicity. It tells you how much zeros there are, or how much they repeat. Write the partial expression for the area of a square whose side is x plus 8. It's simple. It's first area equals length times length times width. So it's x8 times x plus 8. So that equals x2 plus x8 plus x8x plus 8x plus 64. That equals x2 plus 16x plus 64. That's the answer.